Hello students, in this video I am once again explaining the PeterSon solution. So before watching this video you should watch the critical section problem. So then only you are going to understand the PeterSon solution. So what is this PeterSon solution? So this is the solution of a problem. This is a solution to the critical section problem. So what is PeterSon solution? PeterSon solution is a classic software based solution. It is a software based solution. So what is the disadvantage? It works only for two processes. Okay. So now yesterday in last video I have explained the PeterSon solutions, but once again I am explaining here by putting the values of what is the value of flag and what is the value of turn. Okay. So just remember that. So what is the I have taken here for your convenience, that is PI and PJ. So these are the two processes. So PI it may be a P1, P2, or PJ it may be a whatever, P10, P8, like that. So now when the values of turn is equals to I, then the process PI is going to enter in its critical section according to the algorithm of PeterSon's solution. So similarly, when the value of turn is equals to J, then in that case the PJ process is going to enter in its critical section. So now when Vi wants to enter its critical section, then it has to set the value, that is flag of I is equals to true. So whenever the process Pi or Pj wants to enter in its critical section, then it has to set the flag value as a true. Okay, so now I hope you remember the PeterSon solution. So this is the PeterSon's solution. So if I take the two processes as P0 and P1, so I have taken here P0 and P1 processes. So now the two processes are going to be execute in its critical section. So as I told, we have to set the turn value and the flag value. So if the particular process wants to enter in its critical section, that flag should be a true. So flag 0 is equals to true, means the P0 wants to enter in its critical section. So now according to the algorithm, turn is equals to J. So what is the value of J here? J is here 1, because Pi and Pj we have taken. So Pi means it is P0 and Pj is nothing but 1. So what is the value of J here? It becomes turn is equals to 1. So what is the use of turn variable? So turn variable, it indicates that who should enter in its critical section. So turn is equals to 1 means we are giving a chance to a process P1 to enter in its critical section. So we are asking to process P1 whether it is ready to execute in its critical section. So if so means if process 1 is ready to enter in its critical section, then once again it has to set the value of its flag to a true. Once again the P1 is going to ask to a process P0, means turn is equals to 0 according to the algorithm. So now it is going to set the turn as 0. Once again it is asking to a process P0 that whether the process P0 is ready to enter in its critical section. So if process P0 is not ready, then we are going to execute the process P1, right? Why? Because it is ready to enter in its process P1 is ready to enter in its critical section, but we need to check one condition, that is flag of 0 and turn is equals to 0. So flag of 0 means what here? The flag of 0 is equals to true for this. Okay. So and flag of 0 is what? It is a true, right? So now and means and the condition we are checking, and so turn is equals to 0. So what is the value we are having here? Turn is equals to 0. So if both the conditions are true, it is going to be wait. So if this condition or this file will become true, we have to wait, means the process P0 is waiting here. So until and unless the condition becomes false. Okay, so now if this condition becomes true, the P0 process is going to be wait. So now process P1 is going to enter in its critical section. So after finishing its critical section, we have to set flag 1 to a false. Why? Because we are giving some other process to a chance. So if flag 1 is set to be false, then it will come out from the critical section and it is going to enter the remainder section. Clear? So now it has set the flag 1 as a false. Now it is going to execute the remainder section. Remember. So now process P0 is already, as I told, it is waiting for its to enter in its critical section. So now flag 0 is a true now and turn is a 1. So flag 0 is a true and turn is equals to 1. So whether turn is equals to 1 means what? We are once again asking. So if it is not ready, then P0 is going to take a chance now. Clear? So now flag 1 has set, to enter in its critical section, we need to check this again while loop. So flag of 1. So flag of 1 is, as I told, it is a false now. So it is false and turn is equals to 1. So turn has become 1, but flag is having how much value? It is false. So it is F for F and it is true. So for AND condition, the both should be a true to for waiting. While here while loop is going to become false. Flag is false. As I told, we have set here the flag of 1 as a false. So flag of 1 is false and turn is equals to 1. So turn we have set here 1. So 1 is equals to 1, it is true. But F and T means according to the AND condition or AND gate, you remember. So both the conditions must be satisfied or true. So if here the condition gets false, we are giving a permission to a process P0 to enter in its critical section. Clear? So once again it is going to finish its critical section. It is going to set here the flag 0 to a false. Then it is going to exit from critical section. Then it is going to enter in its remainder section. Clear? So now the PeterSon solution preserves all the three conditions as I told in a critical section, that is mutual exclusion. So how mutual exclusion condition is going to be satisfied by the PeterSon solution? What is mutual exclusion? So only mutual exclusion is nothing but only one process at a time can access the critical section. So at same time we are not allowing the P0 and P1 to execute the critical section. So hence the mutual exclusion is going to be satisfied. So what is the second condition must be satisfied? That is progress. So what is progress here? The progress is nothing but if the critical section is not free or critical section is not accessed by any other process, in that case the any other process can enter in its critical section. Means what? If the critical section is not executed by other processes and some other processes asking or allowing is if some other process can enter in its critical section. Okay, the process outside the critical section does not block whether the process from entering the critical section. Means what? Suppose process P1 has finished its critical section and it has entered to a remainder section now. So at the same time the process P0 wants to execute in its critical section, but still P1 is executing the remainder section, so it will not affect the critical section. So hence we may allow the some other process to execute in its critical section. So this is what? Progress. So what is bounded waiting now? So bounded waiting is nothing but only for a certain time the processes are going to be wait to enter in its critical section. Means the no other process are going to be infinitely they are not going to wait. Means we are giving a equal chance. If the process P1 is busy in its critical section, the process P0 is going to wait for a certain time. So for how much time it is going to wait? Until it finishes its critical section, or once it exits from its critical section, then we are allowing process P0 and vice versa. So now all the three conditions are satisfied. So hence the PeterSon solution satisfied all the three conditions, that is mutual exclusion, progress, bounded waiting. So this is what PeterSon's solution. Thank you.